Alright, hello everybody. I know it's been 2 weeks, but oh well. I'm getting lazy, I'm sorry. But actually we got a new iPad. So now we have an Apple Pen, which makes it so that our handwriting is better, even though I already have bad handwriting. Now it's going to be at least a tiny bit better, so hopefully it's more endurable. And also today I actually have a script, so hopefully it doesn't get off track and all. So yeah. My previous video, I answered a question that my friend had, and that was the beginning of a new series, and that's the conic series. So I'm just going to be covering a basic parabola, and just a little heads up, no, we are not going to be covering
like rotated parabolas, like something like this. Like, we're not going to be
covering those. We're only going to be doing horizontal, vertical, and sideways. Just saying, because if you came here for that, I'm sorry. I don't have. Whoa! I just did something great. Yeah. I'm not going to do that today. Maybe I will later. So, what is a parabola? Well, a parabola is the set of points equidistant from a point in a line. That sounds very weird. Basically, if there's a point and there's a line, then it's all the set of points equidistant. So that would be like that. So, bro, that's the same exact thing. You just repeated it twice. That's why it takes the shape of form of a U. And although that does sound very weird, it's at heart it's not that much confusing, and hopefully you'll agree with me by the end of the video. So this line right here is
called the directrix. If I can write, great, directrix. And here is something called the focus. And the point right here, I'll do a different color. I'll do red. Why not? This point right here, which is the midpoint of that line, is called the vertex. Right there, like vertex of the parabola.
And that's pretty much the definition of it. So the horizontal and vertical ones are a bit different, but we'll get to that later. So I'll just write down the formula right now.
Well, there's 3 different equations. First, there's a...
Oh god, my thing. Ax
squared plus bx plus c equals y.
So that's the first form. It's kind of like a standard form. You should only really use this when you're given 3 points. 3 points. Because then all you have is you'll just plug it in for x and y, and you'll have 3 unknowns. And 3 unknowns and 3 equations, that is just a simple system of equations. Yay, it goes down. Okay, I'll actually move this.
I'll move it down here.
Yeah, so there's the first one. I'll do the second one in a different color. My Apple Pen isn't working. Okay, the second version is sort of like the writing a times x minus h squared plus k equals y. And this version is sort of useful for when you are given 2 points, and one of them has to be the vertex. And the vertex, in this case, is equal to hk. Now remember, this can be a trap. Like, it's not really a trap, it's a common mistake that people sometimes make. It's a minus h, not a plus h. So if you're given an equation, like it's x plus 1 squared plus 2 equals y, then the vertex is not 1, 2. It is not. The vertex is actually negative 1, 2. And if you plug that into the first equation, you'll understand why. So make sure that you don't get that negative sign confused. And yeah. Next, this is going to be the final one that we'll be covering, and this one's probably going to be the one that we're going to be doing the most. And this is, I think it's called point slope or whatever. I don't really care about names. Basically, it's x minus h squared equals 4p times y minus k. And by the way, this is only for horizontal parabola. So for all of these, this is only for a horizontal. Let's see if I can write vertically. Horizontal. Yes, I can spell. Yeah. So horizontal these are only horizontal, so make sure that you don't use it for vertical. For vertical, you make sure that you have to switch x and y. So for a vertical, it will be a times y squared plus by plus c equals x. While for this one, it will be a times y minus h squared plus... Wait, no, that's actually wrong. Sorry, I just made a mistake. Hopefully I can edit that out. A times y minus k squared plus h equals x. And hopefully that makes a sort of a bit of sense. Like they're connected here, so same thing, they're connected here. And am I right? Yes, I'm right. Okay, just looking at my script. And with here, it's the same thing. Just make sure that the square terms are different. So like, that is not a y, that looks like a 4. Y minus k squared, that's a k, equals 4p times x minus h. So this is for horizontal. This is for vertical. Make sure you get that because you might make a mistake there. Okay, I'm recording. So I'm sorry, actually. This is for vertical. Make sure you get that because you might make a mistake there. Okay, so yeah. That's actually wrong. It's the opposite, I'm pretty sure. So the first one is vertical and the second one is horizontal. Make sure you get that. I say that people make mistakes on that, and I made a mistake. I feel embarrassed. I'm sorry. I'm a failure. I'm sorry. Okay, bye. Now, what's so special about this equation, okay? What's so special about this? Well, it has a different thing. So, for example, for the first equation, I don't have a cursor, so I'll use this thing. So for this, you have A, B, and C, which are all just unknowns. They're just placeholders, like nothing special about them. I'm sorry, your feelings don't matter, okay? A, B, and C, these things, they don't represent anything. They're just like variables that don't really show you a lot about the graph. However, for this, it at least gives you two important things, and that's H and K. H and K. And that we are shown is the vertex. So for the first equation, there's nothing we can really tell with the standard form. But with the second equation, we at least know two things right off the bat, and that's the vertex. The vertex is x and the vertex is y. However, the third equation utilizes all three variables. If I can... Yes, okay. So, h, that's the h in the vertex. K, that's the k in the vertex. I'm sorry, I'm standing up. And the p. What's the p? Please don't mean that. Well, the p would be, that's the parabola. It would be the distance between a foci to a vertex. So, it would be that. This is p right here. And so, by the definition, a parabola is the set of points I'm going to pray that I can remember to edit that. Okay, a set of points equidistant from a point in a line. So if this point right here, if that distance is p, well then this distance also has to be p, because it's equidistant from a point in a line, so they're both the same distance. That's the same with any point, actually. So this, if that distance is a random number, e. Actually, I shouldn't do e. R. If that distance is r, then this distance is also r. Okay, although it doesn't look like it, it is. Trust me, I'm not a doctor.
It was a reference.
Okay, so your set of points equidistant from a point on the line, and so that's what p is. And how do we know that? Just accept it. I'm not proving that equation today because I don't want to. So yeah, that's what p is, and you guys might also think, what's so special about p other than that? It's just, we know the focus, so what? That's only useful for questions that ask you what the focus and what the directrix is. Not true. It's also important because of the latus rectum. So in a parabola, I'm actually going to take out my ruler here because I'm a tryhard. There we go. So if we do the
Haha, what an idiot. Tutor bros can't even use a ruler.
if we do the coordinate axis, and let's say this is our parabola. Actually, let's make it go sideways. Why not? When it's sideways, the latus rectum would be, well, that's the focus. This is the directrix. The latus rectum would go through the focus. Oh, God. You know what? That's fine. I don't care. So, yeah. The latus rectum goes through the focus, and it goes through two other endpoints. This is useful because the length of the latus rectum is equal to 4p. And you should probably write that down if you're taking notes. Latus rectum equals 4p. And by the way, when you're taking notes, never write down literally everything, because I guarantee you it's going to be annoying later on when you reread it. So yeah, the latus rectum, that's an L, the latus rectum is equal to 4p. I'm not going to prove this either, but just try to accept it, please. So yeah, the latus rectum is 4p, and so you can use this. Let's say we were given HK, the vertex, and we were given, yeah, that's all we need. No, let's say we were given HK and another point. Well, then we can easily find P. And let's say they were asking us, find the focus. Well, then we could just logically think of it. Like, let's say it was horizontal. Well, then, if this is the vertex, we could find out if it goes left or right. And just saying, if the square term is positive, it's up or to the right, I'm pretty sure. And if it's negative, then it's left and down. Just saying, that's for the square terms. And so with using that, with the P, if you have the vertex, you can just move it some distance. Move the point some distance. Like, if this was 1, 1, and we got that P equals 1. Okay, whatever. Let's call that 4, 4, and P equals 1. Well, then we find out that the focus is 3, 4. And then the latus rectum is equal to 4P, which is 4. And so that's sort of how you can use it. You can also use it to find the directrix. And yeah. And there's one last thing, and that's called the eccentricity. In normal conics, eccentricity is just eccentricity. I'll do it like that. Equals C over A. But a parabola doesn't have a C, and I'll tell you guys what that is maybe in the next video. A parabola doesn't have a C. So essentially, you guys, this is just a memorization, just in case someone asks you this or tries to flex their knowledge on you. For a parabola, C equals A. That's pretty much it. So the eccentricity of a parabola is always 1, no matter what. Yeah, I think. Yeah. So yeah, for a parabola, eccentricity is always 1. Just memorize that. Maybe we'll talk about eccentricity in the next video. So yeah, for now, we're out of time. So hopefully this helped. If it didn't, comment down below what problems you had, and maybe I'll do a video just responding to your comments and all. And yeah, thank you for watching, and goodbye.